Hello everyone. In today's video, I wanted to look at a situation that comes up from time to time from our roadway design customers. It's a situation like we see on the screen where we have a side slope design where our first segment coming from the lane or the shoulder has a known slope and width, and the last segment has a known slope and height. In the middle, we have a known slope, but in that segment, we have a variable width. In other words, we would like it to flex based on the height of fill. Let's see how we can handle this in Subassembly Composer. To start with, just like always, we're going to drop a point. And before I forget, I'm going to jump over to our target parameters and create a surface target parameter. Call it EG. Since we're targeting a surface, I'm not going to set this up properly. I'm not going to set up all of my codes and input parameters properly. We've done that in previous videos, so I'm just going to continue here with the geometry and the layout of this subassembly. So the first is, or the first point from the endpoint or the origin is known, and that is a slope and width. So let's go slope and delta x. And remember that was a -3 to 1, and it was 10 feet. And we're going to add length to point, fit to screen. I'll go ahead and move my surface down. So now we're at the end of this first red segment here, and where we'd like to go is to the touchdown point. We can't go 2 to 1 here because we don't know the width, so we're going to reverse the order because geometrically, even in reverse order, this will end up at the same spot. So I'm going to place the 1 to 1 for 6 foot first, and then I'm going to go 2 to 1 slope to surface. That'll grab the touchdown point, place a point, then I'm going to backtrack and place a point, and then build lengths for these last 2 segments. So let's do that. So next I'm going to our auxiliary point, place an auxiliary point. Remember, this is kind of a phantom point, a point we're not going to construct. I'm going to turn off add link to point at the bottom. And we've done this quite a bit in some of my last videos, and this is a very handy tool when you want to go find an intersection or check for an intersection, but not actually place a point there. So we're going to do slope and delta y. That's what we know from that last segment. And remember, that is a 1 to 1 for 6 foot of height. So we're going to do a -1 to 1. That'll be a -6 height. And I'll move my surface down a bit more. So you can see the AP1 placed, just a phantom point. And now we're ready to go and intercept with our slope out of order, the 2 to 1 slope. But since this is our point of touchdown, we're actually going to use a regular point. So I'm going to drag a regular point in, and we're going to do slope to surface. That in between segment, the slope was a -2 to 1. Surface target hasn't updated. Remember this, we'll click off. Make sure I tab through that. Then we'll come back, and there's EG. We'll fit to screen. Let's move this down. Grab my EG. And now if I move it down far enough, you can see P3 forming there. So we placed a point, so we went down at our steeper 1 to 1, and then we went 2 to 1 slope to surface and found that point. Now we're going to backtrack, and we're going to come back that known 1 to 1 for 6 foot of height to place a real point here. So let's drag a regular point in, and we're going to do a slope and delta y. There we go, going from P3. Notice the slope, we need to change this to 100. Remember, that last slope was 1 to 1. I'll fit this to screen. So you can see the direction is incorrect. Notice we have this reverse slope direction option. So there we go. And remember, the delta y on that last point was 6. So we go back at 1 to 1 for 6 foot of height. So we've locked this segment in. And what I'm going to do is I'm actually going to turn off the plate or add link to point. This is not a must. You could go ahead and place it here. I just like to place the links in order of creation. So now that I have 3 real points here, computing that, I'm just going to drag a link in, and I'm going to start connecting point P2 to P4, and then I'll drag one more link in to connect P4 to P3. Fit the screen. So again, we came here, we went down to fake point, found a real point, backtrack real point, links to connect both. So let's test it. So we'll call this solver or solve2, and I'm going to save this name as solve2. On the desktop, we'll close it. Let's go over to my example file here. So I already have a assembly here built with 2 lanes, and I have that shown in cross section. If you see the green line here, that is the existing ground surface line. So let's go to my tool palette here, right click, import. I'm going to pick solve2, add that, right click, refresh image. Now we're ready to left click, place in the file, and escape. I'll move this so you can see it. So now we need to update the corridor with the target parameters. Go to corridor properties, and we'll go to parameters, set all targets. There's my surface, existing ground. Rebuild the corridor. We have a few errors, but that's expected. So you can see here, it looks like it's working well. We found the intersection. So let me go down and grab this section line, or sample line, and move it down a bit. So if you would watch the right side as we increase in fill. So you can see that middle segment, that middle 2 to 1, stretched out. We maintained our 6-foot height here. We maintained our 10-foot wide here. So I hope this quick video has been beneficial. Have a great day.